Please confirm if you can hear me.
Yes, we can
Yes,
hear
sir.
you.
Yes, sir. We can hear
Thank
you.
you, thank you, thank you. And please check if you can see my screen, the presentation. You can see my presentation.
Yes,
Yeah,
yes, sir.
yeah.
It is visible.
Thank you, thank you, thank you, thank you. Okay, so welcome to the statistics for research subject. So this is the first lecture. So this class will start with an overview. So first, generally I try to write on the subject. So mostly after this presentation, probably this is an introductory presentation. After that, I probably write a lot in the whiteboard. So if you want, you can copy the whiteboards, and I'll share some of the my handwritten notes time to time. And this will we'll discuss about this particular subject. As you know, this particular subject is quite a basic subject for any research topic. You might have seen so many research papers where you need to do little bit statistics and you need to add statistical descriptions and all. So for that foundations, we'll try to start from very basic as per the syllabus. We'll start from very basic from the typical mid-median mode to eventually we'll jump in, try to reach such a place that we can discuss the hypothesis theory and all other theories. If please mute yourself if you are not have any questions or none. Okay. Yeah. Thank you. So, if you have any questions, please feel free to stop me anytime and ask about anything. If you are want me to repeat something or some other things, right? So, so this is a basic brief syllabus about the subject. So maybe it little bit lag, generally lag a little bit. So syllabus wise, we'll start with the basic about understanding about the statistics like mean, median, mode, variance, and all these things. So is it visible?
Yes, sir.
Yeah, it is changing, right? Okay. Okay. So variance and all these things are we'll see. We'll talk about the basic graphs and that. But today's class little bit we'll talk about little bit about data also. Like of course, data is a very important thing for any statistical inference and any basics of the statistics. Little bit about data we'll talk about, and then finally then we'll go to the correlation regressions, their interpretations, how the regressions is connected to the estimation theory, and eventually we'll talk about the probability, then distributions, the binomial distribution, normal distribution, all the distributions. Eventually, we'll talk about the joint probability and all this. If time permits, we'll talk a little bit more to go towards higher side, towards the queuing theory. We'll try that if it is time permits. And then we'll go to the main our discuss the hypothesis theory, why hypothesis is important and what kind of hypothesis you can put into the papers or what kind of hypothesis they ask for in the paper. So we try to whatever the permits our syllabus permits us, we can discuss about those things. So this is more or less a small discussions about the syllabus and about your evaluation process. About your evaluation process, so there will be four assignments. Four assignments of each 25 marks would be there. So total should be 100 marks. So total first three assignments would be written assignments. So you have to write it, take a scan of that, and then you have to send me in a Google form or some places like upload the PDF kind of thing. Three assignments would be like that. The fourth assignment would like to keep like a kind of a programming kind of assignment. So of course the statistics has a lot of applications. We'll talk about like applications a little bit later. So of course you need to code. And nowadays I guess codes doing coding are quite simple in terms of the LLM. So till you know that what you need to do and how to deal with the data, that is a good enough for doing any kind of coding. So we can for last assignment would be like a little bit coding and mostly we'll try to do the implementation of whatever we have learned in terms of, say, hypothesis theory and all these things. So on the basis of those things, we are going to do some kind of basic coding kind of assignments. The fourth assignment would be the coding assignment. So the third three assignments, written assignment, just a pen and paper writing and scanning, and the fourth would be coding assignment. So this is the total evaluation process. So, in this first half of our discussion, I'd like to give some basic idea about the statistics. What is the implications of the statistic? Why you are need to use the statistics, and probably eventually when we'll understand and grow more in the terms of the understanding, then probably we'll talk more and more about the research part. How we can add these things into the research. Those things will obviously comes into the picture. So, by statistics. So, of course, statistics has a huge applications on each and every field of our day-to-day life, to any kind of study, any kind of analysis. So basically, all the your basic business analysis or any kind of analysis, if you say, that is actually comes from the your statistical part, right? And say, be it from the healthcare, for basically you are suppose doing some clinical trials. I'll give some clinical trial example later of this particular PPT. So there you will see there, of course, from basic statistics you need to add the statistical analysis part. So from the business economics part, how your market is going to do your basic market research, your quality control, your risk assessment, everything comes under the statistical part. Into the engineering product part, say product design, how your design should go, and how your development you should do. You do some kind of reliability testing phase, process optimization, any kind of optimization in that matter of fact. So those places you have a statistical insights are required. So I'm not going to detail about all the sections. You can see all the different sections where you can estimate that all these kind of statistical calculations and the analysis can be helpful, and those things are gives you some idea of the data. Basically, at the end of the day, we are talking about more about data. So, and the in the this particular world, we are generating probably quite a trillion amount of data. Now the generation of data is gone to the above the zettabyte or petabyte. So on that huge amount of data, what are you supposed to do with the data? So this is the set of analysis, this is the set of kind of a explanation of the data that can be done, that is should comes from the in terms of the statistical analysis section. Now, if I give a basic uh, introduction or the definition of the statistics. So statistics transforms the, say, raw data into the meaningful results. That is the basic requirement. So you got a huge, as I told you, huge amount of data you have. So given that a huge amount of data, how are you going to use that particular data? So that's why the statistics gives you some way to make the raw data into the meaningful results. So in this science behind it, basically have a few steps. So first you identify. So assume you are doing some kind of experiment. So that experiment can be some kind of a risk assessment. That experiment can be, suppose you are working on, say, agricultural some area, you are doing some finding or some kind of crop disaster, distress, or some kind of crop disease, or you're trying to find out some your growth analysis of any kind of disease or any places. So any cases, if this is the situation, if you are defining your um, experiment. So of course, first you need to identify the particular problem, and after identification of the particular problem, you should go and collect the data about that part. So you define the set of variables. On the set of variables, you defined, okay, this is the places where I should define. This is the problem statement. Under this problem statement, these are the variables I should go for, and I defined the data. So I collect the data. And again, the data collections in the terms of that, the data can be a normal, so 1D data, that could be some numbers data. If it is a gas density collections or something like that, it could be a single data density data. If it is a say pressure sensor or the temperature sensor. So you can typically get a pressure, you can typically get a temperature of this particular area. Like this, it could be depends on sensor, what kind of sensors you are using. So basically, you are going to get a 1D data, simple scalar data. It could be 2D data, that could be as a matrix data. It could be a image data. It could be a multiple, the mixture of the different type of data. It could be text plus image data. It could be text plus audio plus image data, and so much different types of data can be possible. So the collection parts come into the part actions. Then after that you should come to the organization part. Organization as in that given that structure of the data, if it is a 1D data, 2D data, 3D types of data, so it can be a homogeneous data, it can be heterogeneous data, right? So if you have only text data, you are generating say text data only, right? So of course, if you are coming from computer science background, you know that there's something is called a database, right? So database can be two types, like a database with some homogeneous data, a similar type of data you have, or it can be heterogeneous data. You got a mixture of the two type of data. It can be a text data plus a video data. Text data plus can be audio data. This kind of things can be heterogeneous type of data. So basically, that organization part generally takes care about the takes care by the different type of database systems. So once the data is organized and it is there with some set of logic and some set of rules, then you are supposed to face the data and then you should go for the interpretation of that particular data. Now this interpretation part is the actual area where we are 90% of our discussion will be basically after assuming the data is coming to us. Now what should I do with that particular data? So like again, maximum our calculations, our discussions will be around the scalar data or say kind of not even matrix data, just mostly into the terms of the scalar data. But you can obviously scale up this particular concept in terms of the matrix data. Matrix can be 2D, 3D, 4D, something in dimensional. Of course, if you go to the towards the machine learning algorithms and all, so it would be in dimensional data, in dimensional features. We talked about that. Even, the concept is same, but you just need to take this concept towards that particular scenario. So interpretation of data, and finally the presentation of the data. Presentation obviously comes from um, the data visualizations. If you have done any kind of the subject and under something is called data visualizations, so that comes under this. Right. So this is the whole process, whole procedure of the statistics. Of course, we are going to talk about more about the interpretation part because that is the place we are having our discussions. So that is the whole story of the journey of our data. So data could be a qualitative data or quantitative data. That as I told that data like you can do a quantitative analysis or you can do go for the qualitative analysis. Quantitative means typically the numbers. Qualitative means how say this. Of course, the descriptive way of doing the data analysis. Of course, there are different softwares for the qualitative analysis, different softwares for the quantitative analysis, and different process also. But eventually, more or less, the concepts are same. Now, statistics makes this information-based decisions. Why are we doing all these things? Because just to make the something, the data should give me something decision-making power. So that is the ultimate goal of our all this scenario. So basically, eventually, I get a decision-making scenario that okay, given this particular amount of data, if this comes up beyond this number, I will probably do this X, and if it coming under that this number, it will do the Y. So basically, this kind of scenario we generally talk about in terms of the basic statistical situations. So this is overall situation is basically the statistics, and this is the power of the statistics. What you should do, go for the statistics. So typically, there are type of statistics. Two types of statistics are there. There is something is called descriptive statistics, and one is called the inferential statistics. Right. So under descriptive statistics, there are two types. Something is called measure of central tendency and the measure of dispersions. Measure of central tendency comes under like mean, median, mode. So what is these things and what are the detailed about these things? We're talking in after few slides. And in the something is called inferential statistics. Inferential statistics are typically like in the kind of regression analysis, estimations theory, hypothesis testing. So all these things comes under the inferential statistics. So basically, our syllabus, basically we are going to talk about these two type of statistics. First, we obviously go for the descriptive statistics and start with the basic understanding of the deterministic type of data. and eventually we try to jump into the non-deterministic type of data, non-deterministic type of events, and we'll talk about the estimation hypothesis and the sampling theory and all these things. So let's see what is the descriptive statistics. Right? So descriptive statistics, let's take an example. So suppose I work on a coffee shop, say, right? So I need to find out that what is the customer satisfaction in terms of the coffee shop. So basically, coffee shop say wants to find out that customer satisfaction's level. I mean, if you are going to different, say Starbucks or cafe or CCD or some places, you might have seen these things happen. So they ask you for your feedback, right? Minimum, I mean, like in 99% cases, if you find out, they ask for the feedback, they ask for kind of ratings, right? So if you buy something from Zomato or say some Amazon, they also ask for the feedback. This is the basically the situation what they are trying to do. Basically, they survey say for say 200 customers, if they are asking you that to rate their coffee, rate their services, so, and typically they also provide the numbers. Like if you put a one, that means that is they are very satisfied. Eventually, five should be very satisfied. So if this is the scale, then they ask you for the rating of this particular scenario. Now, so basically, typically after this kind of exercise, this kind of experiment, what you do, you got a 200 number of set of numbers on the basis of 1 to 5, right? So of course, the 200 maybe I'm just giving an example, it can be 2 million, it can be 2 billions, something like that, right? Obviously, if I think about Amazon, and if they're taking a say rating for all over the world, of course 2 million rating is quite normal, say probably in a few hours, right? So what should I do with this data? So after collecting the response, so they understand. So given that say 2 million set of data if I get, or say even 200 set of data if I get, I need cannot, I mean, I just cannot keep that particular data in an Excel sheet, right? So I need to express, I need to provide such a kind of data which is kind of give a single number which gives you the descriptions of the all the set of data, right? That is the main idea of the descriptive statistics. Basically, it gives a descriptions of a say million of data in a using a single number. That is the main motto of the descriptive statistics. Now, under this descriptive statistics, what are there things are there? One very basic is the mean rating, right? So suppose the average mean rating is say coming as a 4.2. That means that so average customer satisfaction is quite good. So like from that particular number, I can understand because my maximum number is 5. So towards 5, if I get an average number, that means many of the people have given me the 5 star. Basically, from this number itself, you can tell this much. Median scoring is 4. That means the middle value when the all the ratings are given. So basically, of course, it may come like 1 to 5. All the numbers you can expect. So that means that 4 is a kind of middle value, which is quite a high. If you say if you would get a 2 or 3 as a middle value, you would understand that maybe that you're not got. I mean, so basically the numbers. If it is a 1, 2, 3, 4 or 5 this number, so it is a given odd number. If you're getting a 3, that means that you have got a 5 also, but you also got a 1. So by this, if it is a simple set of numbers, from there quite easily you can find out how much maximum, how much minimum you actually have got, right? So those things you can find out from the median. Mode 5, so you got a 5, so that means that maximum number of people have given the number of 5. That is the maximum customers are quite happy. Range, of course, the maximum number minus the minimum number. So 4, that is a widespread. So basically, few people are quite not happy with the particular scenario. If it would be small, say 2 or 3. So given that the mode is 5, so say it is 2 or 3, that could be like the lowest ranking is towards not going towards 1. So that kind of inference you can do from this number. And finally, the standard deviation is 0.8. That means how much your rating is varying from the average, or the maximum people are stick to the nearby the your mean range, that is 4.2. So maximum people are either could be on the 4 or 5, and few people are giving you the 1 or 2s or 3s, right? So basically, so eventually you are doing good in that particular part. So this is the whole scenario. That means that given that from that 1 million or 2 million set of data, if I give this set of numbers, that it represents that 1 or 2 million data. That is basically the power of the your descriptive statistics. So that's why this descriptive statistics happens. So here it is everything is kind of a concrete. It is not like given that this number, this has to become. So there is no probabilistic situation or there is no kind of estimation situation is there in the deterministic section. So after that, the second part where the things comes, that is the inferential statistics. But before that, just to give you the descriptive statistics business applications. So coffee shop uses this descriptive statistic in terms of identify the improvement areas. So suppose the customer gave a low rating 1 or 2 on say you got to say 10 or 15 questions. Under that, suppose some places you got the average as 1 or 2 or so mid or median got a 1 or 2. So basically you can improve that particular area. So enhance the customer experience. So basically, depending on those numbers, you can do a training or improve your service speed and all these things. And finally, you can track your progress. So given that you got to say this is if this is a time series data. So week 1 you got this rating, week 2 you got this rating, and also on. You get this kind of data in terms of the time. Obviously, that comes under time series data. So you can actually find out then how you are improving or how you are not improving or you are stagnant about that cases. So that can be calculation using this process. Yeah. Now next part is the inferential, which I was talking about. So basically, so your typical descriptive data, that means that it is descriptive data in terms of that it is a deterministic kind of situation. Now, in some cases, it may happen that that is data is not deterministic. There is some kind of assumption is coming into the picture because they have no idea that okay, this could be a process. So basically, what we do, we assume something on the basis of the assumption. We try to prove or disprove that particular assumption. That is the part of the inferential statistics. So, a typical example, probably you have come up across this particular example during the COVID scenario, right? So say a pharmaceutical company develops a new flu vaccine and wants to determine the effectiveness of that particular vaccine. I guess quite obvious and common example in the bio science area. Before mass distributions, you are trying to find out that particular flu. So basically, the vaccine is works on a particular flu. So basically, your there should be a design of the study. So typical design of the study is basically find out 5,000 individuals who are this is a human, of course, experiment. You need to take proper action, or proper precautions to do all these things. So 5,000 individuals are there. So they are randomly selected for the study. Say we are now dividing the half of the group who are getting the actual vaccine, the new vaccine, and half of the people are getting the placebo. That is means that you are not giving the actual vaccine. They are giving probably water or something like that, but they don't know the persons who are getting this placebo thing that is they don't know that they are not getting the vaccine. So only the experimental people though are there, they only know that who are getting the actual vaccine and who is not getting the actual vaccine. Now after that, they are left for this environment with this particular flu, and for the 6 months they are there. So now after that, you are looking into the output cases. So after 6 months, if you see the sample data, so for the vaccinated group, we got found out that 200 out of the 2,500 people got the flu. That means that 8% got the infection. For the placebo people, we found out the 600 people out of the 2,500 got the flu. So got the 24% infection rate. That means that the vaccinated vaccine has some impact or the significant impact on the flu for this particular cases. So in this whole structure, so it actually happens like that. Initially, we start with some kind of assumption or the statement that is called basically null hypothesis. That is, we'll of course talk in detail these things about the very end of our discussions. That is the in hypothesis theory, but this is the actual the meaning of the inferential statistics. That is the we initially start with the assumption that is the actual particular vaccine does have no don't have any kind of effect to our to these cases. So now we do the experiment. Of course, the alternative hypothesis that is given by each one is that may have the meaning is that the vaccine has reduced the flu cases. So basically, there is some lot of tests. Things are there like chi-square test, t-test, a lot of tests are there, and that they determine the flu actually basically is registered by the vaccine or not. So given that this experimental data, we find out the effectiveness of this particular vaccine or not, depending on this cases. And there is something is called confidence interval, and all these things are there. So that is not the important part, but the concepts of the thing is that it is given that the inference statistics try to infer the situations in terms of the experimental results, which takes, of course, the help of the descriptive statistics, but it actually kind of a probabilistic scenario. So, of course, in some cases, time after some time, we will of course introduce the non-determinacy of the statistics into the deterministics world. Of course, from this, you can understand this is the basic premises of the our nowadays basic machine learning theories and everything, right? So this is the basis of that, right? So, of course, we'll talk more about these things later. There's another effect is something is called regression analysis that is also part of the inferential statistics. Basically, say you can given that set of data points, if I got say 5,000 data points, I can try to find out the say model, say one kind of set of a model that okay, this is given that this is the scenario, this is the this amount of numbers. Provide this kind of a output, and from their data points, you can find out a model. Say model can be a straight line, model can be non-linear lines, any kind of equations we can generate, and each of that particular line model can be called the regression models, and we can find out the we can predict or we can estimate the future numbers on the basis of that particular model. Okay, after the model can be correct, model can be improved, and all these things are obviously there. Of course, at the end of the day, in our research scenario, we try to create a model on the basis of our data points. That is also, of course, one part of the research. Right? So that is the again that comes from the statistics part. So we'll talk about more about these things when we talk about the regressions. Again, regressions we'll talk about in terms of two states, that is regression normal and regression with estimation theory. So again, two state of discussions will be there. So eventually, this is the two basic set of statistics are there. So in the normal, in the set of statistics, statistic discussions. Right? Now, what is the whole cycle? As you can see, so initially we get the data. So first we start with the visualizations of the data, analyze the data for the statistical models. Then we find out the knowledge by the interpretations of the practical and statistical significance of the models. Finally, we understand, we solve the problem, and then make the decisions on the basis of this by the scientifically sound decisions. And then also, then given that this case, okay, we try to understand, okay, this understanding is correct or not on the basis of the experiment. We get more data, right? So if we get a more data, and this particular cycles keep on going, still you get a better models. Of course, when you do the research, you'll see that we'll read a lot of papers, and on the paper you find out some their limitations are there, and you do the again some research, and you found out a better model of that same problem. Again you try to find out, and you can try to increase the accuracy and so on. So this particular cycle keeps on going in terms of the statistical scenario. So that is the actual research is all about, right? So before going to the our main discussion, that is as I told, that is if you remember the cycle, that is the first we identify the problem, then we collect data, and then we interpret it. The main our discussion is on the interpretation part. So but before that, just slightly, I would like to talk about a little bit about data, right? So of course, I mean, many of you, I guess, work on different farms. So you've got different type of data, different structures of data, right? So whenever you are getting such kind of a secondary data, but a secondary data will talk about data. So basically, it is not generated by or not curated by yourself. If you are using any kind of data, probably you have got different source of data. So please understand, data is not just a thing. Just you just use that. Suppose if I give you some examples, you can see that if I just give you say 11071984, if this kind of numbers are there, that number may look like a birthday, but may not be a birthday, but probably some kind of date of the historical events, or it could be something different that something is called as member ID. So we should understand whenever you are getting any data. So few things you need to ask about the data. Okay, so whenever from wherever you are getting data, so probably some of your friends doing some kind of experiment, they are putting data. If asked for the data for any kind of research, that make sure you ask these few questions when you are using data. First thing is the something is called a structure. Of course, the computer science engineers should understand better because the structures, the data structure, probably you have heard about data structure. So basically, that is very important when you deal in any kind of data. So the how the data is getting presented, right? So it is very important. So if I'm showing it is actually the number. Or suppose if I see the third example, there is something is called CV1 to BT, something is there. So what are the meanings? It is actually the numbers, or it is actually the words, or probably it is a kind of cryptic words. What are these things basically? So if it is to be a postal code, it could be a license plate. Or if given that if it is a license plate, it could be which particular country, which particular city of about. So these things are there. So whenever you get any kind of data, please make sure you ask that okay, what is the structure of the data? What is the this what words or what are the these numbers or words are meanings there, right? So make sure you ask this scenario. Next is the context. On what context you are using this particular data. So the environment where this should be a prior knowledge to you to understand okay what kind of data you are providing, right? So of course the CV1 to BT, if I say suppose in terms of I am saying cyber security region or some kind of cryptic scenario is going on. If I say this number, so the sense would be different. If I talk about some postal code or some kind of say card number or something like that, the number would be meaning would be different. So the context of the data, understanding of the data is very important. Third is the meaning of data, that is the data in a correct structure or placed within the context or not. That is that sense as per the meaning it should be there. If it is actually on the proper place and the proper structure is there or not, if there is some error is there or not, so that should be also understandable. And finally was the this is for what reason you are giving me this particular data. That is the knowledge part, the application of the information. So if I get this data, if I understand the structure or the context of the data, what am I supposed to do with the data? That is also very important to understand. So that is the for any kind of set of data. If you ask these four questions, you should get the actual essence of the data. Suppose now for the same set of data, if I give the some set of informations in the term of these four questions, so then it will become an information. So if you see that this information is the data plus the structure plus the context plus the meaning. If you give this, then it will become an information. Now you can use this information for some kind of a knowledge. Right? So suppose now data structure is given. The first is the month, then is the date, then is the year. Right? So as you see many places, it is shown as DDYY, right? Or YYYY. For this get four Y's should be there. It is DD or MM or DD. These things need to be taken care. Now the context is it is a data. By default, you may have think about okay, this is a Indian data. May not be right. So that's why the context is important. So it is a basically UK data. So I have to think about how my frame of reference would be different now in terms of the context. And finally, the meaning that it is a data of a hotel booking. So now you got the final full understanding of this particular data, full context of this data, because now it is having a full meaning. So basically,
Sir, you are not audible. Sir, we can't listen you.
can you hear me now? So as I was talking about the information, so information is about data plus the structure plus the context and the meaning. So now suppose for the date, the first date, it is about the structure of the DD in MYY, right? So YYYY, four Y's are there. So and given that it's a context of the UK data, so initially maybe we think about the data is a Indian data, so the frame of reference would be different, right? So given that you understand the structure and the context, and finally, if I give the meaning of the data, that data is a hotel booking data, right? The hotel booking data. So probably you can understand, say probably from some text from the say, booking.com, I have found out this context that okay, this is a you get date with the hotel, okay, date of the hotel booking with this particular data structure. So similarly, like all these cases, so always please ask the structure, what is the structure of the data, what is the context, and the meaning. And eventually, of course, once you got this as a information, that means that you now you're ready to do some kind of calculations to fulfill that particular knowledge, what I was talking about the last one. So fulfill the knowledge, then you can do some kind of analysis or some kind of calculations. So for the other examples also, just now what was source of the data for your research purpose, for any other purposes probably. So what is the source of data? So data generally collected source are two types are there. Something is called primary data and another is called the secondary data. So primary data would be the survey and the interviews probably many of you are doing probably. So you go to the people or you go to the some company, some managers or some people. So you go and you have a some set of questionnaires. Probably you can also few of these questionnaires in the emails also to your students, to your some other friends, right? And you got this some kind of a scale is there. So one is the less, one five is the best. Now on the basis of this scale, what do you think about this amount of questions, right? So this is a kind of a primary data for you because you are doing the survey, you are getting the instant result about all these things, and finally you are using that data, right? All the cleaning, data cleaning, other processes are there, of course. Data cleaning, which data are relevant, which data is not giving you the exact meaning of the data, some half data is there, all these things. If you want to interpolate the data, augment the data, all these things are there, of course. But that is the basic source of your data where you want to use for your research purpose. Secondary data, that could be two types. One could be internal data, one could be external data. Internal data would be your organizational data. It could be any case. Suppose for my case, suppose I want to see the students, I do some kind of research on the students, right? So how the all over the subjects they are doing, which particular subjects are getting tough, which subjects they are liking, which are they are not liking. If this kind of research, if I want to do, I go to the organization. If I go to the my academic office, I'll find out okay, this is a set of data. I want to do the work on that part. In this part, of course, I do need different type of process, of course, to get the data for the your primary data. That would be a different scenario. Of course, if there is a human beings and everything are there. If you are writing papers, you know that nowadays it is very serious about taking the permissions, right? So, which set of permissions you need to require specifically for any kind of medical research purposes. If you are talking to people or if you are taking some data about the people, please make sure you take the proper permissions and proper letters from the proper authority to publish any kind of data, right? Those things are there. And finally, the final external data. External data would be government data, private data. Many websites are there from say Kaggle probably quite a popular set, Mendeley, any other government websites from our Indian government websites, weather data, WHO data, World Bank data, all these websites are there. Quite a huge amount of data available. Probably you will see few cities. If you are working on a smart city, probably say city of Sydney. If you search city of Sydney, they would provide you. I mean, they have given every data like in few meters how many trees are there, how many cycles are there, how many post I mean, the traffic lights are there. Everything is there in the particular site. If you find out, so they have given each and every set of data. So basically, given that they using that data, they are trying to make their city more smart in that particular sense. If you can suggest okay, this is the analysis is happening, so probably you could put this kind of traffic light in this particular position. Probably you can put a cycle stand on this particular position. These things you can suggest on the basis of this set of data. So this is the kind of external set of data. So again, data privacy is very important. So if you are doing any kind of research, please make sure you are publishing data. There are a lot of platforms where you can publish the data. So one of the things I generally follow is Mendeley. So you can publish your data in Mendeley. You can get a DUI also there if you upload your own data. And please make sure you keep the integrity of the data whenever you are doing some kind of experiment and you are getting a first-hand data. Make sure keep that integrity of the data and do not make any kind of error in the particular data, because some people are for the other people it is a secondary data and they are going to use that particular data, right? So this is the whole source of data. Next is finally data flow. Probably the industry people will understand data. So initially we got a set of data types. There could be financial data, consumption data, KPI data, normal file data, sensor data, some log data, all the source of data, or the kind of data you are getting. Of course, please understand that for each kind of data types, the type of the structure of the data is generally different. You might have seen something, some harder something like a JSON type of data. That is for the any research purpose in terms of the NLP. If you see, you can find out that this JSON is very popular, right? But which is not same for any kind of a image kind of research kind of data. So if you're getting a huge set of image, that is different. So and if you are downloading some data from the say social media, say from Twitter, or from some say Instagram or the YouTube, or from these cases, if you are getting some data, it has its own structure of data, right? So please make sure you understand the data structure whenever you are dealing with any kind of data types, or depending on your source, secondary source probably. Depending on your source, the data structures can be different. So make sure you understand it as once you're getting the data. Now, once your data is getting, of course, you have to put somewhere in the database. For the smaller case, of course, we call them as a database. But for a bigger purpose, there is something is called data warehouse, data lakes. All these words comes in the picture. So this is not directly part of the statistics, but just to give you the brief idea, like how institutions are dealing with the set of data. So of course, these words comes into the picture. So probably if you're in a Flipkart or Walmart, you have to get the data from here. Okay. Now, once you got the data, then you've got two options. Either you just visualize the data, or you can visualize in terms of the statistical inference of the data, or you just do some kind of a calculations. So you are not actually taking directly the data. Of course, that is also possible options. When you are doing some kind of data visualizations, you can directly put the data, or do some kind of basic calculations and put the data into the dashboards, and you can find out the data. And of course, you can create some reports of the data, say, so for some uh, environmental purpose and everything. If you're doing some kind of creating some set of reports, so basic calculations are good enough for the creating the reports, right? Otherwise, you are going for advanced analytics or data calculations, or those kind of scenarios. If you are going for the advanced cases, it is also possible. So both the cases, so data calculations and everything. This is for the parts of the statistics. So this is the overall data flow situation, right? Now, since I got three parts, now if little bit about the basic vocabulary. What are the words we are going to expect? So first is the variable. Variable is the characteristics of the item of the individual. So basically, some point of time only the next few minutes I'll probably write something as X, Y, Z, something like that. Those are the variables that is basically the variables which are going to get the value. So basically, I'm not going to directly write, okay, this is a sales data. Okay, so sales data, I'm indicating this as a some say X, right? So that is called as a variable. Second is data, of course, the numbers. Data have the different values associated with the particular variable. So X can take the value of say 100, 200, 300, something like that. So that is basically data. That is the population. Population consists of the item of the individuals about which you want to draw the conclusion. That is basically the population on the basically the pool of the data. Basically, you can say on the basis of that, basically, I am going to define the variables, and from there, they are do some kind of calculations. And fourth one is a sample. Sample is some part of the particular population, the portion of the population. Suppose if its population is quite high, suppose the say population of India, and if I need to find out the average age of the India, average height of the particular Indians, so it is very difficult to deal with 1.4 billion set of data. And first I have to collect the all of 1.4 billion data. That is a very huge task, as you know. The census is happening, so this is quite a big task, right? So in general sense, what we do not go to 1.4 billion people. So what we go for, so I take a small set of them and we find out the mean, and there is as a process, given that this small set of samples have this amount of data and this amount of height, so we can predict that okay, this is the population height, something like that is there. So we'll talk about more this in the sampling theory. So population, for a population, I can find out the mean, median, mode, all the parameters possibly. Those parameters, those numbers are basically called the parameters. And for the same thing, if I find out the parameter for a sample, that is basically is called the statistic. Okay, so population is to the parameter, that is equal to sample is to the statistic. Right? So this is the basic calculation. Of course, this population per sample parameter statistics, all these things will come back again in the sampling theory part. So this is the but I was talking about population is a huge number. Even if from that particular huge number, if you find out few randomly some people and find out the statistic around that, and from the statistics you can actually find out the parameter for the population. So okay. Now a little bit about data collections, like how data collections we have talked about, like about the data organization. So data organizations, that is collected just factual materials commonly accepted in the scientific community as the necessary related to research findings. So you need to organize the data. I mean, of course, once you are collecting data, you need to have data somewhere, say in the database, for different structure. Of course, as I told you, different structure are already there. So initial basic few type of structures we are going to talk about. So ways of organizing the data from the research is a frequency distribution table, which is the most popular probably, and we are going to use this step itself. But it is not the only one type of data organization per way. There are some other ways, or something is called a stem and leaf diagram is there, charts are there, chart probably you know, everybody knows. So this is a few sets of structure when you keep the data, organize the data, right? So frequency distribution. So for categorical or the ungrouped data, if you have a determined in order to list the category of the total number of occurrence with each category. Suppose you got say this 10 sets of numbers are there, 10 numbers are there. It's ungrouped data. This is just a discrete numbers are there. If I just find out okay this say 8 is coming for say 2 times, 3 times, 6 is coming for 2 times, something like that. If I do that part, we generally call this as a frequency table, right? So we found out the scores. So for 5, 4, 5, 6, 4, 5, 6, and all. And the number of times these numbers are coming. So suppose 4 is coming one time, say 5 is coming one time, 6 is coming 2 times, 7 is not there, 8 is coming 3 times. Like this, if I find out this set of numbers, eventually we come up with a score and a frequency, right? So this is basically is called the frequency table for ungrouped data. Ungrouped data means this is a discrete set of data, right? So of course, we can for our example purpose, we'll start from the all the examples will start from the ungrouped data. Eventually, we'll go to the group data. So if it is a short number of data, if it is a finite number of data, say 10, 20, 30, probably this is quite a good idea to deal with this kind of a number. But what if the numbers are quite high? If the numbers become quite high, suppose if I see something like this, these numbers, quite a big numbers are there, then it is quite tough to deal with the individual numbers in the particular. If the quite a, simply if I say that the range is quite high, suppose I start from 1 and the end is 100. For each and every number, I can find out and put a tally, and I can keep the numbers like that way, right? So for that particular purpose, I need to do something. It's called the grouping of the data, right? Of course, grouping of the data has some, say, a few guidelines are there. So that like you should be between say 5 to 20 classes. Classes are mutually exclusive. That mutually exclusive means they should not be overlap to each other. Of course, that will generate the ambiguity. Include all classes are even in the frequency. If the frequency is zero, typically all the classes should be even is the same width for all the classes. Ideally, may not be in some places.
Sir, sir, your
Yeah,
computer screen is blinking actually.
thank you.
Yeah, yeah,
Yes. Just keep on blinking.
yeah, yeah. It keep on blinking. Now it is fine.
Fine. Okay. So includes all the classes, even if the classes are even, that is, if the one of the some frequencies are zero also, we can keep the frequency table in the frequency table. Usually we keep the same width of the classes, but special cases may happen that so there is a few last few frequency classes are there where there is no data is there, and there probably one or two some numbers are there, so probably we can club those classes as a, though it is a special issue, special cases it may happen. So of course, some of the frequency must be a total total data set is quite normal. So I'm just given the guidelines out here. And finally, remember to use the zero if the class has no data, of course. That do not keep it as a blank data, right? So these are the basic guidelines for keep making a grouped data classes. So if I just show you, finally, what is the actual table look like? So typically, the table could be say like this. Say 18 to 23, I found out say these numbers on the basis of those numbers, whatever we had shown you. Okay, find out okay, I got a 19, keep a tally. I got a 22, keep a tally. Something like this. If I got a 31, so I'll put a in the table of the 30, 35. I can put a tally like this. Basically, tally means like 1, 2, 3, 4. But from the fifth number, I just put a cross, right? Like this. We had done these things later. I mean, in the basic classes. So that's how basically find out the um, this age and the frequency. Of course, we'll talk more about this particular this class limit and all this. A few words are there. We'll understand the basic vocabulary of a particular table and how to deal with this particular table. We'll talk later in this class in the later class. So this is basically the frequency table for a group data. So initially I have shown you the ungrouped data. This is a group data. Okay. Now the next things quickly you can see that is something is called the schema and lead. Though it is not our part of discussion, just to give you the idea, there is not only one types of things are there. Maybe if you are in computer science engineer, probably you have seen the examples of this in different parts of the algorithms. So basically, test and leave basically try to find out what is the digit on the terms in terms of the right and the left. Basically, suppose your number is 243. Basically, you can write this number as a 24 into 10 to the power 1 plus 3 10 to the power 0. Something like this if you want to write this number. So basically, your left hand side would be 24 and the left would be 3. Why you want to do this? Because you have a set of multiple set of data. So if you see this example, if you have the say in the 90s you got a lot of data, you got in the 80s you got a lot of data. So basically if you do these calculations in terms of this stem, so first you clear this stem one by one and then you go to the leaf. So if you understand the complexity, calculation complexity and all these things, there is a impact of that these things there, but I'm not going there. It is not our discussion portion, but we can do or we can organize the data like this. So basically, we find out in 90s how many data there. So 97 is a part of 90s, 92 is a part of 90s. So basically, we can see 2 is there, 96 is there for 2 times. So that is 6 is coming 2 times. 797 is there 2 times. 97 7 is coming 2 times. So like this, basically, we generate the data. Basically, and if I just take the number 97, so it is a 90 plus 7. That means 9 into 10 to the power 1 plus 7 is into 10 to the power 0. Right? So that's how basically we create the data. So basically, if it's 197, so 1 into 10 to the power 3 plus 2, 9, so 19 into 10 to the power 2, 7 into 10 to the power 3. Like this, basically, we could have create the leaf and the stem for the set of data, and that's how basically we organize the data. This is the leaf, left, and stem type of organizations of data. Finally, for the graph and charts, these are again quite a popular probably graphs and charts. So basically, these comes under the data visualization part. So typically, you got a bar chart, pie chart, line chart, histogram. There are There are ample numbers of charts and everything are there. These are the quite basics. So if you are using the Excel sheets and all, you generally have done these things in number of times. So just to give you the idea, so like bar chart is a composed discrete bar. So basically, typically if you deal with the discrete type of data, so you got the few quarters data with the frequencies. If you want to show the data, so basically this is the way you can show the bar charts, right? Second would be your pie charts. Again, if you got a discrete numbers with say, for households, you got the internet, electricity, grocery, and other things with the set of amounts. So total amount is basically is equal to the 360 degree. So basically for the each ratio, so the particular amount, 1000 by total number into 360 degree, that particular angle is basically gives you the particular area into the pie charts. So that is another way to express or organize your data in terms of a circular situation. Third one, the line chart, simply put a point on the 2D axis. In the x-axis, you got the your days or your any attributes, and y-axis you got the numbers. You put the numbers, and eventually this particular line chart is you can see it as a piecewise linear line chart. Piecewise linear in the meaning is that between this 29 to 33, these numbers, it is a linear. 33 to 36, it is a linear. So, but eventually the not all over line is it. This is not a linear situation, but partly these numbers are linear. That's why it is called the piecewise linear. So this piecewise linear concept we are going to use into the modal median also. So please remember this. So this is the meaning of the piecewise linear. So that is the line chart simply. Last one is the histogram. So basically for a group data system, group data, if you're having a group continuous kind of a data, so you can see, and if you want to put the frequencies on the basis of this, we generally use the histograms for the this kind of structures data, right? So finally, in terms of say, if I just say in terms of the business statistics or any kind of statistics, you can say. So this is a method that involves using statistical techniques and the tools to obtain useful insights from the data available to the organizations. This is written as a business statistic, but it can be any statistics. This is the whole motto of our full discussions in this particular presentation part. Now, of course, we understood the power of the statistics, right? So this is a quite like a understood like what are the properties, what are the things we can use the statistics, where you need to use the statistics and everything. But of course, everything has its limitations, right? So the statistics will also have its own limitation. It is not that it can give everything for in the terms of the understanding. So the limitations, if I want to show you, this is something is called. This is the limitation of the statistics. I guess it is in the terms of it is not it's not a presentation mode. I'll send you the presentation mode. You will see that things have changed. Basically, if I give you the mean of x, y, and the correlation and all these numbers, you do not if I do not show you the pattern on the left hand side, it is not possible to understand. Okay, that what particular structure it looks like. If I change this little bit, if in the right hand side there is some numbers are there. So if I change the status these numbers, it probably will keep on changing this particular structure. So if I do a minute different in terms of your mean, median, standard deviation, and the correlations, your structure of this data would be different. Of course, this is a descriptions of a million set of numbers. A particular million set of numbers, how it would look like, that statistics do not tell you, right? So that is kind of a statistical limitation, you can say. That's why the data visualization or the data visualization system, these particular subjects come into the picture. That I want to understand in terms of the visualization pattern, how the data looks like. Of course, there, of course, for the similar type of or different type of structured data, you might find out a similar mean, similar median are coming, right? So that's why this is a kind of a you can say the limitation of the statistics that it does not give you the actual scenario, actual structural data, or if you want to find out any pattern from the structured data, it is very tough to find out that. So this is the introductory presentation in the terms of the statistics. So we will go to the our typical pen paper type discussions. So just let me. So I guess you can see my blank screen. So as I told that of course data is collected, right? Data is collected as we assume because as I told the interpretation part is the important part of our discussions. So as I have the data in terms of say good data, right? So ungood data, of course, there are examples. So the area of examples we'll talk about, but we'll talk a little bit about the group data, how we generally deal with the group data. That is very important to understand. Probably some point of time in your this research, you go and get huge amount of data, and probably you create this frequency table, and you need to if you do need to calculate the basics. So that's why you start with the very basic. So what are the numbers I had shown you in the terms of the age and everything? That is something is called the class interval. Okay? So it is called the class interval. This is called class interval, and of course the further terms of this is for the class frequency. So let's take some example. So we will do a lot of examples in this class. Suppose I got the say this is a class interval in terms of nothing but the age, right? So for the set of age, I found out okay, this many people are there around this class frequency. Now if I talk in terms of the statistics, it tells this is called nothing but the 5 to 59. So observe as I told you initially, the class sizes should be same, which I have not taken deliberately, of course, because I want to something that's why I didn't keep you the numbers as the same. I mean, keep the weight as the same, right? So this is the basically typically if you for a group data, this is the class frequencies. So this is called the in the terms of the statistic, we use called the class interval. Now, for the class interval, the lower numbers, whatever the lower numbers you can see here, these lower numbers are called the class limits. Okay, so class limits two types. So basically, there's the class limit. We got two types. One is called lower class limit. It's called upper class limit. So of course, this lower class limit are 15, upper class limit are 19. Just I'm writing 20, 24, 25, 29, 30, 34. 35, 44, 45, and 59. Okay. So these are the lower numbers are for the lower class limit, upper are for the upper class limit. Okay. Next is something is called the class boundary. Important to understand because class boundary is generally something which is you are going to use when you are going to create the so when we are going to make the calculation of the median and the mode. Okay, so in lower class boundary and something is called the upper class boundary, right? Now, how should I calculate the class boundary? Okay, so the class boundary is something which, if you see, the data is not continuous in terms of the our interclass intervals, right? So it is ending with the 19 and the starting with the 20. So suppose if some point of time if I get a number 19.1, that is very tough to keep that. Where should I keep this, right? So for this case, I need to make this as a continuous. There should not be a discrete kind of symbol. Wherever it is ends, first the one set of class, the next set of class need to start from there. So we can make a consensus on that part that okay, if that exactly that number comes, which part you should put, but otherwise other numbers there should not be any kind of ambiguity that okay where should I put and all these cases. Right? So for that case, what should I do if this particular scenario happens? So first we can need to find out. So something is a little bit confusion may happen that basically there are similar two types of words are there for this particular class. We find out something is called the class width. So for this particular wording have this different name in different books. So this particular thing is basically nothing but the lower class limit of say next class, whichever class you are intending to find out, minus upper class limit of current class. So if I say this is a D, so suppose I'm assuming the class is of this. This is the my current class. Assume this is the current class. If this is the current class, then lower class limit of the next class would be 25. This is the lower class limit for the next class, that is 25. And upper minus upper class limit of the current class, that is a 24. So I got the class with D as a 1. Again, please remember that this particular word is for particular book. It may vary with the different types of books, but the concept is same. So it is the D, right? D is coming as a 1. So it can be anything. It is not a kind of hard and fast rule that it has to be 1. It can be zero point 0.5, it can be 0.005, it can be 0.01. I'll show a few examples that it will be something, some weird numbers would come, right? So this is the class weight. Now what we'll do, so I'll give half this number, this if I'm getting 1, half this number to the current class, half the number to the next class. So basically my lower class, sorry, my lower class boundary would be, and this generally this particular D, this class width generally be same for all over the problem. In generally in 99.99% cases it happens that it stays same number. So lower class boundary would be the lower class limit minus half of D, and the upper class boundary would be upper class limit plus half of D. Okay. So this is the scenario. So suppose if I take the again same lower, this is 20, right? 20 is the number, lower class boundary should be 20, lower class boundary minus half of D. So that should be, so just LCB 20 minus half of D, that is the 20 minus half. Sorry. Oh, uh-huh, uh-huh. So it should be 19.5 and the 20, that number is there. If I want to find out the UCB for that, that would be 24 plus half of D, that is 24 plus 0.4, that is 24. Like this we can find out. So you can understand this 0.5. So let me write it here. So of course for the first and the last case you can say that okay, I do not know that what is the previous class or the next class, how should I find out? So as I told, the 99.99% cases D would be same, so you can assume that okay, this 0.5 would be same for these classes also. So for the lower class boundary should be minus 0.5, upper class boundary plus 0.5. So it should be 14.5 minus 19.2, 19.5. It will be 19.5, 24.5, 24.5, 29.5, 29.5, 34.5, 44.5 to 44.5, 44.5 to 59.5. Right? That's how basically you can find out, and you can see now it is there is no gap. Of course, I need to make a consensus. If I just 19.5 or 24.5, all this number comes, then where should I put? Otherwise, there is no gap as such in this particular case. So that is basically is called the lower class boundary and the upper class boundary. So this is, please remember, we are going to use this lower class boundary and upper class boundary when we are going to talk about um, uh, median and the mode. Calculation of the median and mode, we need these numbers. For mean, this is not required. I will show for mean and standard deviation what is required. This is the class boundary. For the now mean and the median, I can keep it here itself. The something is called the class mark is there. Okay, class mark. So for the mean and standard deviations and all this kind of numbers, mean and standard deviation or variance, we generally calculate the class mark. Class mark is nothing but your lower class limit plus upper class limit divided by 2. That's it, basically. So 15 plus 19 by 2, that would be your class mark. So for this it would be 27, 20, 17, 17, 22, 27, 42, 39.5, and 52. So these are the something is called class mark. Class mark is nothing but the addition of the two class limits divided by 2. Class boundary would be from coming from the class width. Find out the class width. Give a minus of the half of d from the lower class boundary plus half of d from the upper class boundary. This remember these few things. Few more numbers I should define. That is something is called frequency density. Frequency density is the class frequency divided by the width of the class. Now the confusion sometimes is this is the width of the class. This is not the class width. Okay, width of the class is nothing but the difference between the class boundaries. If you see this class boundaries, the difference between the class boundaries is the width of the class. So if I just erase this class mark and I want to show you the class boundary here, sorry, width of the class here, because I need to show in terms of these numbers. So which is called width of the class, right? Width of the class is, again, please don't make sure if you are having this kind of scenario, do not find out the width of the class from the class intervals, right? So if you do not do the upper class limit minus lower class limit, rather than you should use the lower upper class boundary minus lower class boundary. So in this case, you can find out 10, 5, 5, 5, 5, 5. This case it would be 10, and this case it would be 15. Ideally, generally width of the class is same, but as I told you, some special cases, if the frequencies are quite small, we generally increase the width of the class. Again, this particular width of the class is also called as a class width in some books, so that's why this confusion comes into the picture. So if you need to find out the width of the class for these cases, just find out the upper lower class boundary minus it, whatever numbers are coming. This is basically your class width of the class. Now to find out the frequency density, what you have to do is basically find out this individual class frequency divided by this width of the class for each and every case. So for the first case, it will be 37 by 5, next will be 81 by 5. When you will come to 35 by 44 class, it will be 9 by 10, and for this case, it will be 6 by 15. Like this, I just give the numbers there. So it will become 7.4, 16.2, 8.6, 0.8, 0.9, and 0.4. These are the numbers we should find out in terms of the class density. Okay? So class width frequency divided by the width of the class. And the last one is something is called the relative frequency. What is the relative frequency? Relative frequency means you just simply add these frequencies, whatever number this frequency additions you are going to get, divide on, if you suppose, if for this case you are going to get a 200, so 37 by 200 would be your relative frequency for the first class, 81 by 200 would be relative frequency for the second class, and so on. Last one was 6 by 200 for the relative frequency for the last class. So just summation of the all the frequencies, and basically we are doing a normalization in terms of the frequency. So individual frequency divided by frequency, whatever numbers you are going to get, that is the something is called the relative frequency. Start right frequency. So class frequency divided by total frequency. So for this case, again, I'll just put the numbers. Like 5, 405, 215, 112, you can check these numbers. And eventually, since you are doing the class frequency divided by total frequency, if you add all the frequencies, of course, it will become a class total frequency by total frequency. So if you add the relative frequency, always it has to be 1. Okay? So that's for sure. It has to be 1 always. Next. Now with this concept, let's come to the another concept, something is called the cumulative frequency. So cumulative frequency means that given that if I keep on adding the frequencies, how it looks like. So cumulative frequency are again of two types. One is called the less than type, and one is called the greater than type. Right here, the things should be there. Something is called the lower class boundary. You can get either. Generally, we generally take the lower class boundary LCB. You get it. So the low, I mean, you can find out for say later part I will show in the terms of the mid and median how we can calculate. So basically, um, you can find out either of these cases. You can find out less than type also. You can find out the greater than type also. In the first case, lower class boundary. What are the lower class boundary we could have here? So if I come back to this typical problem, the lower class boundaries are typically this left set of numbers. So lower class boundary 14.5, 19.5, 24.5, these numbers will come. So one thing is that if I am using the lower class boundaries, I would take last frequency, last class boundary is the 59.5, assuming that if there is a hypothetical class is there, the starting point would be this particular number, this particular the last upper class boundary for the last class would be the hypothetical the starting of the lower class boundary for the next hypothetical class. So I will take that when I will put the numbers, you will see why I am putting that. First, I will just put the lower class boundary numbers into that table. So I'll just put 14.5, 19.5, 24.5, 9.5, 34.5, 44.5, and hypothetical last lower class boundary 59.5. So first set would be keep this lower class boundary numbers. Then I have to find out the cumulative frequency. So lower class boundary less than 10. So the statement would be keep keep looking into this particular table. So the statement is if it is a 14.5, below the 14.5, how much frequency if you have below 14.5?
Please off your mic.
Yeah, below 14.5, how much frequency is there, right? So if you see, observe into this particular table, below 14, it is your frequency is now 14.5 to 19.5. You got the frequency 37. So if I ask below 14.5, that should be 0, right? So that is the part of the less than table. Less than 14.5, how much frequency is there? Next, suppose 19.5 is there. 19.5, how much frequency is there below 19.5? That time 37 will come, correct? Below 19.5, how much frequency is there? 37. Now if I come 24.5, below 24.5, how much frequency is there? That is 37 plus 81. Below 29.5, how much frequency is there? 37 plus 81 plus 43. Like this, it will keep on coming. That's why now you see, if I that since I have taken this hypothetical frequency of 59.5, that means below 59.5, all the frequencies should be there. That's why I have taken that hypothetical 59.5 frequency. So below 59.5, the total frequency will be there. So now if I just write the frequencies, just keep on adding from your standard table. Below 14.5, there is no frequency. Below 19.5, you got the first set of frequency, first class, basically frequency. Below 24.5, first class plus second class frequency, that is 118. Second, below 29.5, first three additions, 161. First four addition, 185, 194, and final hypothetical frequency is going to give me the total frequency. That is the basically the concept of the lower cumulative frequency for the less than type and the more than type. For the less than type, not more than type, sorry, for the less than type. Less than type always start with the 0 because below that nothing is there. 59.5, below 59.5, below the highest upper class frequency, hypothetical lower class frequency for the next class gives you total frequency. What I'm doing, I'm just telling you in a bit. Now let's understand further in terms of the greater than types concept. So it is as if the 14.5 is the below, like above 14.5, how much is there? That is the statement would be. So above 14.5, like if everything is there, so this is just the opposite. So you got the full frequency 200. So always if you start with the 200, of course you come from here, it ends with 0. That is the opposite scenario. Now the similar case for above 19.5, how much frequency should be there? Correct? Above 19.5, that means that above 19.5, you are losing the first frequency set, it is the 37 set. This is a little bit, you need to understand, just repeat the sentence, like above 19.5, how much frequency is there. So that means that 14.5 to 19.5, that frequency you are losing. That's why you are getting this particular frequency. So that's why it will become a 163. Okay. So similarly, if you keep on using the frequencies from, I mean, the highest frequency minus the first frequency, highest frequency minus first frequency minus second frequency. Like this, if you keep on coming, you will find out the more than type 52, 39, 15, and the 6. Right? So this is the cumulative frequency in the greater than type. You please remember either of this. Generally, you do not use the greater than type. Generally, very popular is about this less than type scenario, and generally use this to find out. We are going to use this particular concept to find out the median and the quartiles. So that's why. So basically, of course, many of you have used to find out the median in terms of the some equations. So I'll show you the how the equation came actually. So this is one way to find out the medians in using this quartiles situation. Now, why am I doing this particular less than type upper greater than type? So if I try to see these concepts in terms of a graph. So if I have the frequencies in this and I got the lower class boundaries in this particular one. So if I start with say 14.5, so 14.5 by default my frequency is 0. So I'm assuming this, or this is not 0, 0, this is 14.5, 14.50, right? Next, of course, will come the 19.5. 19.5, I got something as a 37. So I'm assuming this is the number. Say after this 24.5 is coming. 24.5, I am getting some numbers here. 29.5, I'm getting something like here, like this. Usually, what I'm having a straight line. Better not to keep the straight line. Let's make it little bit. So first is flat, then little bit high. Third one is little bit more high, like this. So as I told you, this particular types is called piecewise linear graph, right? As I told you in the line chart, this is a piecewise linear chart. So this particular part is linear. This particular part is linear. This particular part is linear. But it is from this point to this point, it is not linear. You cannot say this is linear because if I just want to add this, it would look something like this. That's it is a linear, but it is not like that. So that's why I'm telling this is called a piecewise linear situations. But good thing about this particular scenario is that though it is since frequency cannot be negative, this is an increasing graph. This is an increasing graph, and I know some point of time if I put in terms of relative frequencies, eventually it will become a graph in between 0 to 1. Right? So there, if the frequencies will be these numbers, the frequencies, sorry, I'm just putting the opposite. These are the frequencies. Sorry. This is the LCV, this is the frequency. So eventually this sides you get a point system, but eventually it will get come as a one, right? So many graphs like sigmoid graphs, any other types of graph you have seen, those actually initial stage is this piece. So that is basically the cumulative frequency graph, right? So from good thing is about this particular graph is that suppose in this particular scenario, I know the value for 14.5, it is 0. I know the value of 19.5, it is some numbers like 37. For 24.5, I know this is 37. I know this is 1 and 8. These numbers I know. If somebody asks me in between this, suppose in 20 or 21, how much the frequency should be, how the table I have no idea. So I have made by default this is a continuous type of problem using a group data concept, but that does not give me, suppose given that this scenario, this is this kind of discrete numbers 21, say 25, these numbers, how much frequency should be there, that is not possible to find out from the particular table. So to find out for the unknown lower class boundary, I can define of course upper class boundary also in the same process. Lower class boundary, if I want to find out that on that particular frequency, how much frequency it should be, that can be found out using this particular table, using this concept of the piecewise linear graph. Why it is important? See, one assume suppose this particular section. So in this particular section, what is there? I'm just drawing one particular section. In this particular section, you know this is 19.5. You know this is 24.5. This particular value is 37. This particular value is 118. These four values you know. Now suppose I want to find out something in between, say 22. In 22, how much frequency should, right? So how can you find out in this particular case? How what is the process? If I want to find out in this case, what is the case value? How can I find? So in this particular scenario, since there is a straight line, that means that one thing is fixed here. That is the slope of this particular line is fixed. Please remember this your class 7, 8, 9, 10. Sometime you have heard something about the slope of the line, right? Slope of the line. How should I find out the slope of the line? So basic equation was the slope of the line was, remember, y2 minus y1 by x2 minus x1. This number, as I of course I know all this number. So if I take these as a y2 y-axis, 118 minus 37 by 24.5 minus 19.5. This is my slope, right? The slope is fixed for all over this part. This slope is fixed for only this particular part. Of course, if I go to the next, jump into the next part, then the slope will change. That's why that is the beauty of the piecewise linear. For this cases, you need to fix the which interval you are talking about. So this is your slope. Slope is fixed for every each and every cases. Now assume, forget about the higher part. If I just define only this particular part, so now what is the cases? I got 19.5. This is equal to, I'm writing this equation. This particular number I have no idea. So suppose I'm putting as a y minus this 37 is equal to 22 minus 19.5. That is the new y2 minus y1 minus x2 minus x1. Right? So one variable, one equation. Suppose I can easily find out this particular y value from this particular case. So that's how basically, given that in this given that particular interval, I can find out that what is the unknown frequency given that unknown lower class boundary. So that lower class boundary can be your median, that can be your mode, that can be anything, or that can be your quartile values also. So that's how basically we find out the median and the quartile values in terms of this particular concept. We'll talk this about more, but I think I will take a break of 15 minutes now. That's 11:35. So 40, 45, 50, 11:50. Let's meet at 11:50 again, and we'll continue with that. I'll show an example on this. Then we'll jump into the basic mean and medians. So let's take a break now for 50 minutes. So we'll stop here, and we'll come back at 11:50.